Hi, everyone. Thanks for joining us for our INA podcast. So lately, Silicon Labs has been making the news for our growing IoT business. However, with our recent acquisition of the timing modules business from Pulsar, that might have some investors and customers saying, wait, you guys do timing also? And so with a resounding yes, so this acquisition itself shows we are heavily invested in timing. And I actually have plans to discuss it in a later podcast. However, today we have Linda Lua, Senior Timing Product Manager for Silicon Labs, joining us to give a fundamental understanding of our existing timing business. Thanks for joining us, Linda.
Hi, Isaac. Thanks for having me. It's always nice to be here to chat about, all things timing.
Yeah, I love having you. And so for those listeners just learning about our timing business, who are the major timing suppliers we compete with, and where does Silicon Labs stand compared to them?
Yeah, so we compete with several competitors, and actually the timing world is serviced by just several suppliers. And mainly, we compete a lot with IDT, who was recently acquired by Renesas. I think last year, early 2019, they just closed the acquisition. And other competition is Microchip, and Microchip comprises of several timing suppliers that they acquired through acquisition throughout the years too. So Microchip now has comprised of Micrel, Zarling, which was also acquired by Microsemi. So they have a few organic group as well. And other than that, we also see TI, Texas Instruments a lot, and also ADI. So Silabs is an industry leader in revenue growth, and we grew more than 20% from 2017 to 2018. And we're slowing down a little this year due to macroeconomy conditions. I'm sure many of you understand that, but we're still in a very healthy position due to our very broad-based portfolio and also with more than 2,000 customers. So we're able to reap the diversity and not get too affected by just a few big customers slow down. So our position in the market right now, we still have the most new products being introduced every year. And we have a very strong R&D investment for new products with a very healthy roadmap expanding into 5G wireless and also synchronous Ethernet 1588. So digging a little deeper into the competitive landscape, we are the industry leader in jitter attenuators, and we have a very complete portfolio of oscillators and also clock generators. Recently, we've been increasing our portfolio in wireless, which TI and ADI get most of their revenue today. And lastly, Microsemi is the dominant leader in synchronous Ethernet and IEEE 1588, and we are not lagging far behind. We're introducing new products in this market as well, and we're very excited with the new acquisition of Pulsar.
So with this competitive landscape, what's unique about our timing technology that makes us stand out?
We have three technology which makes us stand out. So first is our patented technology called the multi-synth. So multi-synth is our version of fractional divider, and our multi-synth enable us to do any frequency synthesis with consistent low jitter at 0 ppm error at the output. So this enables us to generate different output frequencies with only one device to reduce the number of clocks used. Second is our DSPLL. This is a digital and analog PLL all in one, and our DSPLL technology is used in all our jitter attenuators, and it eliminates the need for external VCXO and loop filters. So it enables low jitter and any frequency clock generation other than jitter cleaning. And the third is our timing devices. All our timing devices have on-chip regulation. So on-chip regulation optimizes jitter performance, and it simplifies the customer's onboard power supply filtering. So this helps greatly reduces the number of passive components on the BOM, and also it makes the design a lot simpler.
For someone who is new to the timing world and industry, can you talk a little bit about different or commonly used timing components?
Yeah, sure, absolutely. So let's start with the most elementary and simple form of timing, and that is known as a quartz crystal resonator. And it is exactly what it is called. It is a piece of quartz rock in a hermetically sealed package. So if you put an electrical signal to it, you get a sine wave output. Silicon Labs, we do not sell crystals. But that being said, most of our timing devices do need a crystal which will sit outside our timing devices to provide a reference frequency to our clocks. Another timing component is the crystal oscillator, which we also call the XO, and it is based on a quartz crystal. But we package our silicon PLL die inside a package with a quartz crystal. So with this combination, it will provide a square wave output. And there is also a specialized type of crystal oscillator, which is called a voltage control oscillator, or commonly known as a VCXO, which has a voltage input. So as you vary the voltage input, the output frequency is skewed by a certain number of ppm. And this type of crystal oscillator, the VCXO, is primarily used in broadcast video and communications applications. So something to bear in mind that, crystals and crystal oscillator, it only supports one output. And some designs need more than one output. So in cases like this, we have another timing device known as a clock generator. Clock generator uses a crystal resonator as a reference output. And inside the clock generator, we use a high-frequency PLL and combined with output dividers, the clock generators can generate multiple different output frequencies in different output formats within one device. So this helps, again, reduce board space and system costs by eliminating the use of multiple discrete components like crystals. Another type of timing device that we want to talk about here is a jitter attenuator. So jitter attenuator is very similar to a clock generator, except that it synchronizes to an input clock and it filters the jitter of the input clock. The jitter attenuator can also generate more output clocks in different formats, single-ended or differential, or a combination of both. Typically, in a jitter attenuator, there are additional features like redundant input hitless switching and also status monitoring. So these features are typically not available in clock generators. And last but not least is a clock buffer. So a clock buffer is a very simple device. It simply distributes many copies of the same frequency. Some buffers may include capabilities like signal format translation and also voltage translation. And some buffers may include a PLL, and these buffers are known as zero delay buffers. Zero delay buffers are very specific to certain applications, and one of the applications is PCI Express.
Okay, I see. And of all of these timing components you mentioned, which of those are included in our timing portfolio?
All right, that's a very good question. So Silicon Labs timing portfolio is very complete, and we have all the devices that I talked about earlier, with the exception of quartz crystals. So we have crystal oscillators, we have VCXOs, clock generators, jitter attenuators, and also clock buffers. And Silicon Labs timing portfolio has some of the best-in-class jitter performance, and our clock generators and jitter attenuators can achieve less than 70 femtoseconds of RMS-based jitter, integrated in the bandwidth of 12K to 20 meg. And our Ultra series oscillators can achieve about 80 femtoseconds. That's our best in class. And these are some of our highest performance parts. We know that there are applications which do not need such high performance, and we also have solution for what we call more low to mid-grade performance parts. So we have a clock or a solution for every different application. Other than that, we also have a family of PCI Express clock generators, zero delay buffers, or also known as ZDB buffers, and also simple clock buffers that support PCIe Gen 1 to Gen 5. Another application-specific family that we support in our portfolio is the synchronous Ethernet and also IEEE 1588. So again, with the acquisition of Colstar, we now have a very complete 1588 solution, both in hardware and software.
Okay, so with this full and broad timing portfolio, what sort of applications or designs are best suited for these products?
Everything. So all design needs some sort of timing devices, but we can talk about a little bit more about our focus markets. So our focus for Silicon Labs timing, we focus on communications, data center, wireless infrastructure, and industrial. So when we are defining our new products, we look to these markets to define our new products because these are the key markets that we are focusing on, and they are driving the new standards when it comes to timing products. So if you have a design needing a timing solution, feel free to send it to us and we can work on the clock tree for you. Or you can go to our technical support page on our website and you can also send us your timing requirements and then we will reply you with a solution.
All right. So I'm going to stop you right there.
Okay.
You use this phrase that I hear all the time. So what is a clock tree and how do I grow one?
It is not very hard, but it doesn't come from a seed, unfortunately. So let's talk about what a clock tree is. So if you look at all the timing requirements in a system design, usually provided by a clock generator or a jitter attenuator, and this provide clocks to different endpoints like processors, system on chips, ASICs, FPGAs, high-speed SerDes, data bus interconnects, memories, and PHYs. So what we want to understand from a design or from our customer is the frequencies, the number of outputs, signal formats, jitter requirements, and any additional features that's needed. So from this information, we can develop what we call a clock tree solution. Okay, this will require some imagination now, okay? So when we draw a tree, when we draw a clock tree, the clock device is normally on the left-hand side, and the devices that the clock is driving is on the right. So each frequency driving the endpoint is connected by an arrow from the clock to the endpoint, and we have multiple arrows going from left to right, which is from the clock to the endpoint. So if you turn this picture anti-clockwise 90 degrees, the diagram becomes like a tree. So with each of the arrow as a branch, then there you go. You've got yourself a clock tree. And a clock tree is actually a very common used term in the industry.
I see. So I guess I should become more familiar with that term. I also hear about customers requesting reference designs since it seems to make things easier for them to design in our clock parts. Do we have reference designs we can share with them?
Absolutely. So customers strive to bring the design the fastest way to market as possible. So reference design is one of the ways that can reduce their design time. And one of the objectives in our timing business is to make timing as easy as possible to design for our customers. So we have many reference designs for FPGAs, PHYs, switches, network processors, GPUs, and so forth. And our partners are Intel, Xilinx, MACOM, Broadcom, Qualcomm, NXP, AMD, Inphi, just to name a few. And we have reference design guides on our website, which is updated constantly. So you can definitely go to our website and look for it to refer to it. And we are also constantly growing our design partnership, reference design partnership with more and more suppliers.
That's great to hear. What other resources do we have to help our customers?
So we have the state-of-the-art development tools to help our customers. And one of the main tools that we use in our timing group is called the Clock Builder Pro, or also known as CB Pro. And the CB Pro is used to help configure custom part numbers for all our clock generators, our jitter attenuators, and our oscillators. Other than that, we also have another tool specific for PCI Express. It is the PCIe Clock Jitter tool, and this is used to generate compliance test reports. Other than that, we also have evaluation boards to help with initial evaluation. We have app notes. We also have a knowledge base on our website so that all our customers and engineers can go into our knowledge base to look for some, commonly asked questions or have some discussion within the technical community. But if you prefer a human touch to support, we also have an excellent team of FAEs and also factory application engineers to help as well. We strive to make designing timing as simple as possible for everyone.
I see. So I'm going to try to take a stab at summarizing some of the key takeaways for this podcast. So
Great.
number one.
To see if you're listening.
Let's see. So number one, as you said earlier, timing is needed in all designs.
Correct.
Okay. Silicon Labs also has a complete timing portfolio for pretty much everyone's clock tree needs. So that goes from the oscillators, the clock generators, jitter attenuators, buffers, and I feel like I'm missing one.
No, that's about it. Synchronous Ethernet 1588. Some people like to make that as a separate category as well. But
I see.
But pretty much you covered it all. And sometimes I think this may be overwhelming for some people. So, or you don't want to go through so many part numbers or different product families. So definitely, anytime, just send us a request and we will give you a timing solution as soon as possible.
Yeah, that's definitely very helpful. And so with such a broad portfolio, the key differentiators to our competitors across the board with our portfolio is frequency flexibility, jitter performance, integration, and we also have, I read about this, high power supply noise immunity.
Correct. Yes.
All right. And then last but not least, the state-of-the-art development tools and resources you mentioned at the end. We have that to support making timing designs as simple as possible, and our customers can find those located at www.scilabs.com.
Yes, that's right. So we hope that this will make it a little bit easier for all our listeners to understand about timing and also what Silicon Labs timing portfolio consists of.
Okay. Well, Linda, I appreciate you taking the time to talk with our podcast today, and I look forward to doing more in the future.
Yes, thank you. Thanks, Isaac. Thanks for having me.